Good day, people. This is tutorial number 16, which is called an ellipse generating mechanism. I'm doing this thing in a playlist which is called Kinematics in the 3D Experiences platform. So the one that I'm going to show you right now is going to be is done in the release 2025x of the 3D Experience. Now, we have a setup like that made of essentially a base, two blocks which are traveling down this path, and then a rod which has, as you see later on, there are two revolute joints between the rod and this block, and one between the rod and that block. So if hypothetically, if you attach a motor to one of these revolute joints so that this bar turns continuously using that motor, what's going to happen is that these blocks are going to travel along that track, and the tip of this rod is going to traverse an ellipse. Okay, so these are the dimensions that I'm going to be using, and just to point out, these are, let's say these are in inches, and uh, right, and uh, see this pin is going to go into that hole of the block, and this pin is going to go to the hole of the other block. Okay, and what I was talking about, you can attach a motor here to one of these. This, for example, and makes the rod turn continuously about one of the blocks, or you can attach a motor to this one, etc. Or you can push this prismatic joint, one of these blocks along the track. Eventually, the bar will rotate and traverses an ellipse. Okay, now this particular tutorial that I'm doing is coming from, you can see that chapter 10, Ellipse Generating Mechanism, which is a book that I did 9 years ago, and didn't update that. So instead of updating the book, what I'm doing is preparing these video tutorials to show you the new interface functionalities and icons. Okay, so let's go ahead and do that. Okay, here is the interface. So right click, insert 3D part, and I'm going to use the properties to put a prefix base in front of it. So that's going to be doing the base first. Base. Say okay. Now to make it, double click on 3D shape. So okay, on a convenient plane, on this plane, I will sketch. Okay, I'll sketch a centered rectangle. Now, if I want these two to be the same size, of course you can make them both 10, or you can select this and you use the control key, say equal, so they're going to be equal. Now you can dimension, you need to dimension only one of them, 10 inches. If you try to dimension the other one, it'll tell you that's already 10. So exit, and then I'm going to pad it by 1 inch. Okay. Now I'll draw one of these tracks here. So on that horizontal plane, on that plane, I will sketch. There are different ways of doing it. This is how I'm gonna go, but that's entirely up to you. So let me make a rectangle here, centered rectangle. Okay. So first of all, the dimension. This is 1. And I want the distance from here to there to be half an inch. Actually, it really doesn't matter how you want to do that, but anyway, let's let me try this thing. Let's exit to see whether that's the right dimension. Yeah, from here to here, I want it to be half an inch. So let's go back there. So the distance from this line, control that line to be 1/2 inch. Okay, exit. And then we make a pocket all the way through, all the way to the last. There. Now, you can make one of these on the other side, but I'm going to do it a different way. So here's I'm going to do it. Circular pattern. I don't want to do the whole solid, current solid. I want to just do the pocket. And I want to do a complete crown. So complete crown. There. Complete crown. Right there. Select the axial reference. And now you want to, for the reference axis, you want the axis that's going up. Now in my situation, because I've moved my axis, this is the y direction, right? This is the y direction. So right click the y direction, good. And I want 4 of them. This is another way of doing it. I mean, if you want, go ahead and please go ahead and make another pocket on the other side. Okay, so that takes care of this. So we go all the way to the top. Now let's insert our block. So right click, insert 3D part. The prefix to that, I'm going to make it block. Right click, properties. Call this thing block. Block. And block. Okay, let's go make it. Double click on the block on a convenient plane, on, for example, that horizontal plane, which in my case is ZX, of course, because of the way I've done things. I'll sketch. So that's going to be 1 by 1 square, something like that. Once again, this control that equal to each other, and then dimension one of them. That's going to be 1. I'm going to make a circle in the middle. Remember, this is supposed to fit in there, and it does. Now I'm going to make a circle in the middle, and just for bookkeeping purposes, I'm going to make that radius based on the slide diameter 0.5. So that's a radius, so 0.25. Okay, good. Exit, and then pad it by a height of 1.5 inches. Okay, good. So that is the block. I have a feeling that this, for bookkeeping purposes, I think this actually should be diameter 0.5. It was a little bit thicker in the slide, so good. That's better. This is more consistent with that drawing. Very good. Now I need another one of these. I can copy this and paste it, or so the different for the second block, there are different ways of doing it. Either make a copy and paste, or you can use this. So you go all the way to the top. See that? You go all the way to the top. You click on that, left click on this. So you go all the way to the top, assembly. Left click on this, and that shows up, linear multi-instantiation. I'm going to make 2 of them. In fact, if you look at it, there is 2 because you can change it to as many as you want. So that'll do it. So we say okay. Notice that 2 of them are created. So this is the original one that I made, and this is the instance of that. Okay, and yeah, let's move on. Let's go ahead and do the what's the next part that I'm going to do? I'm going to do this rod. Okay, so let's go make it all the way to the top. Go to the top. Right click, insert 3D part. And I'm going to change the name of this thing so that it starts with the rod. rod, rod. Okay, and let's go make it. All right. So on a convenient plane, whatever is convenient, Z, sketch. So the length of this thing, I made it 1.5 by, that width doesn't matter. I'll make it 1.5 or maybe 1. Oh, sorry, 15 and 1, not 1.5. Let's make it here. There we are. I'm going to dimension this thing. So this is going to be 15. Okay, this is going to be 1 based on the drawing. Then I'm going to draw 2 circles here, one over there. I'll position it properly now. So this is diameter 0.5. Okay, good. And another one here. Same thing, diameter 0.5. And these are 3 millimeters apart. So let me dimension it from here to here. 3 inches, not millimeters, 3 inches. And I want that thing to be 1 inch away from there, just for consistency purposes. From here to here, 1. Good. Exit. Now I want this to turn into a pin and this thing to be thickened, okay? Now, if you do a pad of this, there will be holes here, and you can do the problem, but I'd rather make these pins. So in order to do that, well, I could have drawn this rod here, and then on it draw a circle and pad it. But the alternative is to use the multi-pad. Okay, multi-pad. You select that sketch. It tells you that there are 3 curves here. So if you want a hole, make the height 0. But if you don't want the hole, so for example, if you look at this one, let's find out what this thing is. I want a height of let's say I don't know, maybe 0.25, point 0.1. Let's see how it looks like. Preview. But that's this fellow. That was this thing that I don't want it to be 1. So let me put this thing back 0. That may be your rod, the actual rectangle. So let me make it point 2. Let's see how it looks like. Preview. Yeah, that's this. Now, if you want these pins to be going up, so go make sure you make it more than point 0.2. So 0.4, for example. See that it's coming from the other side. Actually, let me make it maybe 1. Preview. See that? And then this one also 1. So multipad is useful for certain purposes. Again, if it's too much work, you just draw a circle and pad it. Now that's pretty much it. So all the way to the top, save everything. Save everything. And now we start our assembly process. Okay. So first thing we're going to do is to make sure that everything is, well, something, the base is fixed in space, okay, or anchored. Okay, so we go here to the engineering connection, fix, and it's the first one. The first one is fixed. Good. Okay, now let me create a prismatic joint between this block and this pathway over here. The way to do it, you go to, again, engineering connection. Where is that? Prismatic. The different templates that you can use, I'm going to be using axis to axis and plane to plane. I'm going to be using this. And I'm not going to worry about the controlled entity, because at the end of the day, I'll put a motor. Think about it as putting a motor at one of these revolute joints. So the motion of this prismatic joint is not controlled. It's basically dictated by the motion of that motor. So I'm going to be using this axis to axis, plane to plane, and don't worry about this bottom piece. Okay, so this axis or this edge and that edge. Okay, and then, for example, this plane and that plane. There are other choices that you can have. And since I'm not going to be controlling this, so I'm going to put the cursor there, delete it, left click and then delete it, and then say OK. And no. Okay. So if you want, we can move this thing so that it is in that block if it makes you feel better, although it really doesn't matter. And there are different ways of doing it. For example, you can say, where's that? Here, manipulate, translate along that direction so that it makes us feel better. That's all. Good. Now I'm going to put this block in that other slot. So another prismatic joint, same one. Use this template, uh, this edge and that edge. And for example, it's entirely up to you. Uh, this plane and that plane. And once again, since we're not controlling that motion, put the cursor there and delete. And no. Okay. Now let's put this pin inside of that hole. So that's going to be a revolute. I'm going to put the motor later on there. And so we go to the revolute. Where's that? Revolute. Different templates. And the way I'm going to do that is, for example, I like this one, axis and axis, plane and plane, and then the angle between two planes that are appropriate. So I'm going to use this template. So this axis and that axis, okay, this plane and that plane, good. And for the angle, I'm going to use a vertical plane, of this block. So if you go to the block, it's right here. This is the block, vertical plane, for example, y-z plane of the block, and the rod. So where's the rod? There's the rod, the y-z plane of the rod, and then we say OK, and no. Finally, I'm going to place this guy in that hole. So that's cylindrical. You don't have to make it revolute because of the dimensions that I made. This is going to end up in the right spot. So I'm going to go to cylindrical. Different ways of doing it. We don't need to control it. So for example, we can do axis to axis, axis to axis. And these we don't want. We're not going to control. We're going to delete that. And we're going to delete this. And then we say OK. And no. And update. There we are. Okay. How can we check this thing? Okay. Now we want to make sure that things are working fine. So here's what I'm going to do. I will go to this angle. See that in the revolute right there? See this revolute? Double click on it, left double click on it, or you could have left double click on the angle. And I'm going to make this angle between those two planes that I picked, for example, 45, and see what happens. Right now it's 0. They're parallel to each other. See 0. Say OK, and then say OK, and then update. Update will actually move this block, you can see that, to where it's supposed to be. Okay, so it is actually working fine. I don't have any problem with the constraints that I put in there. Now, let's go with the rest of the problem. So we go to, let me first save here. We go to mechanical system design, mechanical systems design, create our mechanism. Okay, And now check what we've got. There is a fixed part. There is a prismatic. Notice that there is no control associated with it. Remember, I deleted those controlled boxes. There's the other prismatic one. There is a Revolute one that I actually made it angled. Think about it as angle driven. Remember, I specified the angle between those two planes and I changed it so you could see that. And this is a cylindrical that cannot be driven either. So there's a good check. There's a good green sign here, check mark. Now we can check it. If you go to mechanism player right there, see that? There should be only one radio button, one sliding bar, because this is a single degree of freedom. And as I drag this thing to different places, this will actually move. So it is doing what it's supposed to. And the tip, right now, this is just a sort of a cartoon animation. There's no physics here, okay? So reset. Now we'll just go put some physics in it. Now, in order to do that, you cannot do it in mechanical systems design. This is just for animation purposes, cartoons. You go to the mechanical systems, not design, experience. Say OK. Create a simulation. OK. Now, before I do that, I'm going to put some physics here. So cancel that. Let's go put some physics in there. So what is this thing? OK, good. All right. Now, let's put some physics in there before I create my simulation. I'm going to put a law excitation. And for the support, we select that, remember that control that I did, that angle-driven constraint that I put in there? Select this command and f of x to put the physics in there. So suppose I want this thing to be going around at 60 RPM, a 60 turn underscore MIN, the times, there's the time. So it's going at a constant speed. Several join is going at a constant speed of 60 RPM, which means one cycles per second. And then we say OK. We say OK. This is going to be a physics. Now we create and by the way, let's actually, for example, put a probe here so that you want to know what is the speed of that point. So here's a probe. We select that point. Say OK. All right. Excitation was created. That's our physics. A probe was created because we want to trace the velocity of this point, for example. And then we're going to create a kinematic scenario. This is the excitation that we created. You push it to the right-hand side. The probe, this is the probe that we created. You push it to the right-hand side. And how many seconds? So let's make this thing maybe for now 3 seconds. And obviously, this is the time step that you have to reduce it. Otherwise, the motion is going to be very jagged. And then we say OK. And now we run it right there. We are in mechanical system experience. We're going to run it or compute it. It is too fast. We're going to change it later on. But now, first of all, look at the results. Here is the results. Actually, let me go back. Let me go back and change the time. That was too fast. I don't like that. I'll put down maybe 0.01. Say OK. Do it again. That's better. I like that better. 3 turns. Okay. Now, if you click on View Scenario Results, deselect all. All I want is the velocity of that point. velocity of that point. So where is that thing? Linear velocity of that point. And if you click on the tab plot button, plot tab, uh, 0 meters per second. Hang in there. Maybe I've selected the right thing. Let me go ahead back here to the specification. Oh, this is Z linear velocity. Sorry, I don't want that. No wonder it was 0. Magnitude is what I want. Magnitude. You click on the plot. Obviously, you're going to get a periodic motion. Okay, so that's good. That worked. Close it. There's physics here. Now, suppose you want the trace of this point. The trace of this point, you click on the geometric trace. You select that point, and then we say, okay, there is your ellipse. So if you take this thing and move it there, see, you have to copy and paste it. Do this. No, I guess I have to copy paste. Copy. Let me see for a second. Copy, paste. There is the ellipse. So if you go back to simulation and animate it, you see that that is going to be traversing an ellipse. One more thing, and that is if that point, if this point was exactly halfway between that pin and the end of the rod, that ellipse would become a circle. All right, good luck.